This is a presentation on famous mathematicians. Pythagoras of Samos. Pythagoras of Samos was a well-known mathematician. He was born in Greece in 578 BC and is often hailed as the first great mathematician. Pythagoras is remembered today for his famous theorem in geometry, the Pythagorean theorem. The Pythagorean theorem states that the sum of squares of the two sides of a triangle equals the square of hypotenuse in all right triangles. Pythagoras also made important discoveries in astronomy. He believed the universe was spherical because the sphere was the most perfect solid figure. He also taught that the paths of the planets were circular. Euclid is a Greek mathematician born in 330 BC. He was the first to prove that there are infinitely many prime numbers. He also devised Euclid's algorithm for computing the greatest common divisor. He is known for having written the most permanent mathematical works of all time, known as the Elements. The Elements comprised of 13 gigantic volumes filled with geometrical theories and knowledge. This would then go on to arouse the Western world in a series of mathematicians around the globe for over 2,000 years, breaking all boundaries and defining new ones in the field of math. In fact, the Elements is still the basis for high school geometry, making Euclid the leading mathematics teacher of all time. Archimedes of Syracuse was born in 287 BC and was an outstanding Greek mathematician, inventor, physicist, engineer, and also an astronomer. Archimedes produced formulas to calculate the areas of regular shapes, using a revolutionary method of capturing new shapes by using shapes he already understood. By this so-called method of exhaustion, he effectively homed in on a value for one of the most important numbers in all of mathematics, pi. Although Archimedes did not invent the lever, he discovered the reasoning behind why it worked. He is known for his famous quote, "Give me a long enough lever and a place to stand, and I will move the earth." Hypatia of Alexandria was born in 370 and is known to be the first woman to make a substantial contribution to the development of mathematics. Hypatia made a strong effort to preserve the Greek mathematical and astronomical heritage in extremely difficult times. The early Egyptian mathematician, Diophantus, had his algebraic equations refined by Hypatia. She is credited with commentaries on famous mathematical works, including conics and arithmetic. These works have been lost, although there have been attempts to reconstruct aspects of them. She invented the astrolabe for ship navigation and devices for measuring the density of fluids. The astrolabe was also used for water purification. The great 7th century Indian mathematician and astronomer Brahmagupta wrote some important works on both mathematics and astronomy. Brahmagupta established the basic mathematical rules for dealing with zero. The rules are 1 plus 0 equals 1, 1 minus 0 equals 1, and 1 times 0 equals 0. Although his understanding of division by 0 was incomplete, he believed that 1 divided by 0 equals 0. Brahmagupta, however, realized that there can be such a thing as a negative number, which he referred to as a debt, as opposed to fortune. He expounded on the rules for dealing with negative numbers. For example, a negative times a negative is a positive times a positive is a negative, etc. Furthermore, he pointed out quadratic equations could in theory have two possible solutions, one of which can be negative, because 3 squared equals 9, and negative 3 squared also equals 9. Al-Khwarizmi was born in 780. He was a Muslim mathematician and astronomer whose major works introduced Hindu-Arabic numerals and the concepts of algebra into European mathematics. Al-Khwarizmi's important contribution was algebra. The word algebra is derived from the title of a mathematical text he published in about 830 called The Compendious Book on Calculation by Completion and Balancing. Al-Khwarizmi wanted to go from the specific problems considered by the Indians and Chinese to a more general way of analyzing problems, and in doing so, he created an abstract mathematical language which is used across the world today. His book is considered the foundational text of modern algebra. The 13th century Italian Leonardo of Pisa, better known by his nickname Fibonacci, was perhaps the most talented Western mathematician of the Middle Ages. In particular, in 1202, he wrote a hugely influential book called Liber Abaci, in which he promoted the use of the Hindu-Arabic numeral system, describing its many benefits for merchants and mathematicians alike over the clumsy system of Roman numerals then in use in Europe. Fibonacci is best known, though, for his introduction into Europe of a particular number sequence, which has since become known as the Fibonacci sequence. He discovered the sequence while considering a practical problem involving the growth of a hypothetical population of rabbits based on idealized assumptions. He noted that, after each monthly generation, the number of pairs of rabbits increased from 1 to 2 to 3 to 5 to 8 to 13, etc., and identified how the sequence progressed by adding the previous two terms. This was the first recursive number sequence known in Europe. When we make squares with those widths, we get a nice spiral, which can be found in abundance in nature. The numbers of the Fibonacci sequence has also been found to be abundant in nature. Many species of flowering plants have numbers of petals in the Fibonacci sequence. The spiral arrangements of pineapples occur in 5s and 8s, those of pine cones in 8s and 13s, and the seeds of sunflower heads in 21s, 34s, 55s, or even higher terms in the sequence. A Frenchman of the 17th century, Fermat effectively invented modern number theory virtually single-handedly, despite being a small-town amateur mathematician. He went on to discover several new patterns in numbers which had defeated mathematicians for centuries. Also, throughout his life, he devised a wide range of conjectures and theorems. He is also given credit for early developments that led to modern calculus, and for early progress in probability theory. One example of Fermat's many theorems is the two-square theorem. This theorem states that any odd prime number will be the sum of two square numbers if, and only if, it leaves a remainder of 1 divided by 4. For example, if you take the number 13 and divide it by 4, you will get 3 with a remainder of 1. So this number meets the qualification to use this theorem. 13 can be rewritten as 9 plus 4, which are perfect squares. So 2 squared plus 3 squared equals 13. This theorem works no matter how big the prime number is. Descartes was a French mathematician and philosopher born in 1596 in France. In 1637, he published his groundbreaking philosophical and mathematical work, titled The Discourse on Method. It was in this work that Descartes first proposed that each point in two dimensions can be described by two numbers on a plane, one giving the point's horizontal location and the other the vertical location, which have come to be known as Cartesian coordinates. He used perpendicular lines, or axes, crossing at a point called the origin, to measure the horizontal and vertical locations, both positive and negative, thus effectively dividing the plane up into 4 quadrants. The German mathematician Leibniz was born in the 17th century. Leibniz's notation and his way of writing calculus is the one still used in mathematics today. In addition to calculus, Leibniz rediscovered a method of arranging linear equations into an array, now called a matrix, which could then be manipulated to find a solution. Leibniz paved the way for later work on matrices in linear algebra by Carl Gauss. During the 1670s, Leibniz worked on the invention of a practical calculating machine, which used the binary system and was capable of multiplying, dividing, and even extracting roots. It was a true forerunner of the computer. He is usually credited with the early development of the binary number system, which is a base 2 counting system that only uses the digits 0 and 1. Because of the ability of the binary to be represented by the 2 phases, on and off, it would later become the foundation of virtually all modern computer systems, and Leibniz's documentation was essential in the development process. Ada Lovelace was born in 1815 in England. As an adult, Lovelace began to correspond with the inventor and mathematician Charles Babbage. He asked her to translate an Italian mathematician's memoir, which analyzed an analytical engine that was a machine that could perform simple mathematical calculations. It was also able to be programmed with punch cards. It was considered one of the first computers. Lovelace went beyond completing a simple translation. Her notes on the engine included what is recognized as the first algorithm intended to be carried out by a machine. Because of this, she is often described as the world's first computer programmer. In the 1750s, Robert Simpson noted that the ratio of each term in the Fibonacci sequence to the previous term approaches with ever greater accuracy the higher the terms, a ratio of approximately 1 to 1.61803398887. This value is referred to as the golden ratio, also known as the golden mean or the divine proportion. Essentially, 2 quantities are in the golden ratio if the ratio of the sum of the quantities to the larger quantity is equal to the ratio of the larger quantity to the smaller one. There are countless examples of how it is found in both nature and in the human world.